to dry cell, we call as a Leclanche cell, or since zinc and carbon are the electrodes in this battery, we call it as a zinc carbon battery also. It is a simple battery and most used. So the anode in this battery is a zinc metal container. So our zinc can, or we can call zinc cup. So this is a zinc cup. You can see zinc inner case anode, and cathode is graphite. Actually, this is the graphite, and this graphite is inert in nature. So it is an inert electrode. Graphite rod acts as an inert electrode, and it is surrounded with the manganese dioxide paste. So manganese dioxide involves in the cathodic reaction at this graphite. Next, electrolyte is a aqueous paste of ammonium chloride and zinc chloride, and this manganese dioxide also mixed with this ammonium chloride and zinc chloride, and a starch to avoid the leakage. So by adding the starch, it is made like a paste, and this paste is less likely to leak. So in this way, the graphite is completely surrounded with this. So this is here you can see this is in cream color, and this is all paste of manganese dioxide, ammonium chloride, zinc chloride, in which starch also mixed. So this is a important one. Zinc anode, graphite cathode, manganese dioxide, ammonium chloride, zinc chloride paste is used as a electrolyte in this dry cell. Now here this is the cell notation or cell representation we can see. So zinc anode is converted or oxidized. Zinc is oxidized to Zn2 plus. Ammonium chloride, it is not involving in the electrochemical reaction. And manganese dioxide, here the manganese in plus 4 oxidation state is converted to manganese oxide, that is manganese into plus 3 oxidation state. So here this is the cell notation or cell representation. And the net output voltage, the output of this battery is 1.5 volts. The constant voltage of this battery is 1.5 volts. Now, so here we can elaborate the construction of this battery. So in detail, when we see this type of batteries you might have seen. So they are they are mostly all the batteries are in cylindrical shape. At the top of it, we have a brass cap. So this is a brass cap. You can see here it is mentioned. So this is the brass cap with a plus symbol, and also at the bottom we have negative contact made here. This is also a brass plate covered here, and this entire cell, the entire cell is covered with a plastic sealing. Okay, plastic cover or plastic seal is used, or insulating seal, insulating, used as a insulating cover or insulating paper to the battery. You can see this is in gold and black color. It is a plastic paper or polymer paper, and inside we have a zinc can. So this zinc can, which is acting as anode in this cell, and at the middle of it or center of this battery we have the graphite rod. Now this graphite rod is completely surrounded with the ammonium chloride, zinc chloride, manganese dioxide paste. So this is all the paste which is surrounding the battery in this graphite electrode, and it is mixed with this starch also to reduce the, to prevent the leakage of this electrolyte from cell. Now come to the working of this battery. So here at anode, zinc is oxidized to Zn2 plus. Zinc is oxidized to Zn2 plus by releasing the two electrons, and these two electrons involve in the reduction reaction at the cathode. So near cathode is graphite and it is an inert electrode. So there the manganese dioxide is involving in the reaction. So manganese here it is in plus 4 oxidation state. Manganese in plus 4 oxidation state. it is converted into plus 3 oxidation state. So plus 4 to plus 3, remember this point. So it is the reaction occurring at cathode. Manganese plus 4 is converted into plus 3 oxidation state. Manganese dioxide is converted into manganese oxide in the reduction reaction of the cathode. Now the net cell reaction or net reaction we can write here, zinc giving rise to, zinc plus manganese dioxide plus the water, and which is converting or the reactants we obtain is Zn2 plus manganese oxide and hydroxyl ion. So a alkali is formed in this reaction. So these reactions are called primary electrode reactions. Primary electrode reactions. Only these reactions contribute to the EMF of the cell. Only these reactions are producing the electricity. So that is the reason they are called as primary electrode reactions. Now we have a few more reactions which we call secondary reactions. Secondary reactions in the sense they cannot contribute to the EMF or they do not produce electrical energy by undergoing any change. So here these are the secondary reactions we can see, and the alkali, that is hydroxyl ion produced in the primary electrode reactions, that is reacting with the ammonium chloride in the cell, ammonium chloride which is there in electrolyte paste. So it it reduces that ammonium chloride to ammonia gas, so converts ammonium chloride into ammonia gas. This ammonia is likely to leak out. So to avoid that ammonia leakage, here it is also mixed with the zinc chloride. So Zn2 plus written there and chloride minus is written on this side. So in between we have ammonia. So this ammonia is converted into a zinc ammonium chloride metal complex. So it is stabilized. Ammonia is converted into a metal complex and stabilized. In this way we can prevent the leakage of ammonia. So these are called secondary reactions, and in this dry cell these secondary reactions cannot be reversed. The secondary reactions cannot be reversed by passing the electricity into battery. That is the reason the dry cell is a non-rechargeable battery. It cannot be recharged and it is only a primary cell. Since secondary reactions are irreversible, this battery is a primary battery. Now overall cell reaction we can write by combining the primary and secondary reactions. Zinc plus manganese dioxide plus ammonium chloride giving rise to zinc ammonium chloride, manganese oxide and water. So this is the working of the battery. So primary electrode reactions involving or producing electricity, whereas secondary reactions they do not produce or they do not contribute to the voltage, and they cannot be reversed by passing the electricity, and this battery is acting as a primary battery. Now applications, you might have seen these applications can be used for small portable appliances. So small portable appliances mostly they require small amount of current, like flashlights or clocks, watches, remote controllers, Walkman, radios, transistors. In olden days we used to see that transistors, etc. So all these devices they require small small amount of current. In those cases these dry batteries are very much useful. And come to the advantages of it, it is a cheaper battery. Dry cell is very cheap and works without any leakage. It is a leak proof cell, and it has high energy density, high current density, the whatever the output of 1.5 volts. So as long as the cell has contains the active materials or reactants, the cell produces voltage of 1.5 volts constantly. So it has a high energy density, non-toxic and there are no liquid electrolytes in this battery because the electrolyte is made as a paste. And the disadvantage, voltage drops due to buildup of reaction products around the electrodes when current is drawn rapidly from it. So the whatever the products formed surrounding those electrodes, they interrupt the current supply. So voltage may drop. So this is one drawback, and it has a limited shelf life because the zinc is corroded by the faintly acid ammonium chloride. So they may damage the zinc cup or zinc can present in it. So shelf life also very less, and the shelf life this battery is about 6 to 8 months, and they cannot be used once they get discharged. This is a main drawback of the primary cells or this dry battery and this dry cell. And the EMF decreases during use as the material is consumed. Not only that, this battery has a problem that even it is not in use, it may likely to undergo discharge. This is these are the disadvantages of the primary battery, that is the zinc carbon battery or dry cell. Thank you.